Hi, this is Prashant Bharadwaj. Welcome to the segment on trade-offs and project crashing. When you are a project manager, these are some of the situations that you may face. The project can be behind schedule. The completion time has been moved forward after the project has started or after the contract has been signed. And the other most important thing as a project manager in terms of trade-offs is to understand the three types of costs involved in projects. One is the direct cost. These are the costs that can be attributed to particular activities or tasks in the project. So going back to the simple example of a construction project, if you have 5 painters assigned to your project and they all work for 3 weeks on your project, the direct cost associated with the painting activity will be the total cost incurred for the painting job or the painting task is the direct cost. You can attribute that directly to painting, to foundation, to electrical work, plumbing, heating, ventilation, air conditioning, on and on. Then we have the indirect costs. Indirect costs are the costs that cannot be attributed to a particular task or an activity. These are for the entire project. So for example, if you have a construction project again, and if you bring in a trailer for the office staff, for the project manager, and the trailer itself costs few $100s per week to rent, that is an indirect cost. That will accrue for every week that the project is in place. But you cannot attribute that to a particular activity. Telephone costs. You may have a secretary assigned to the project. The project manager's salary itself is an indirect cost. So indirect costs are directly proportional to the length of the project. The longer the length of the project, higher the indirect costs. And as you can reduce the time taken for the project, the indirect costs keep reducing. Then you have the penalty costs. Penalty costs are when you exceed the time taken for the project beyond a pre-specified or a pre-agreed upon deadline. So if the construction project is not completed by March 1st, the builder will get $10,000 less per week of delay in the project. So these are common clauses in contracts pertaining to projects. Now, very rarely, there may also be incentives to get the project done early. Financial incentives sometimes can be a bonus if the project is completed in advance. But there are a lot of intangible benefits anyway of completing a project ahead of schedule. You can get your crew, your project manager, assigned to the next project. If it's a software development project, you can get your entire team working on the next software. So the three costs associated with project management are direct costs, which are attributable to specific activities or tasks, indirect costs that occur over the span of the project, not able to be attributable to specific tasks or activities. Penalty costs are the costs that are incurred if the project is delayed beyond the pre-specified deadline. So what is this term crashing, project crashing? It is shortening the duration or reducing the total cost of the project. That is project crashing. We will discuss that in more detail now. So how do you crash a project? The only way you can crash a project Again, keep in mind, crashing means reducing the time taken for a project. So how do you reduce? The only way you can reduce is to reduce the time taken for specific activities. Can you reduce the time taken for the entire project by reducing the time taken for any activity? The answer is no. You have to think about which activities to crash or reduce time taken for. The first obvious thing is it has to be a critical activity. If it is not a critical activity, then you will not be able to get any benefit. Even if you reduce the time taken for an activity which is non-critical, the total time taken for the project will still be same. So you will still incur the indirect cost, you will still incur the penalty costs, but by reducing the time taken for a particular non-critical activity, you would have incurred more direct costs. I hope all of you understand that it definitely costs you more money to reduce the time taken for a particular activity in terms of direct costs. Going back to the painters, instead of the original plan of having 5 painters working for 3 weeks, now if I want to get the job done in 2 weeks, there can't be any magic other than you schedule overtime, or you schedule more painters, or schedule 2 chefs, all of which will take extra direct costs. If you reduce the time taken for a critical activity, great. Then there will be some increase in direct costs, but there will be some decrease in indirect costs, and probably some decrease in penalty costs. So let's look at our checked points. The amount by which an activity is crashed is in fact permissible. So going back to this painting example, you want to go from 3 to 2 weeks. Yes, possible. 1 week you can reduce. But keep in mind, going from 3 to 2 is reducing the time by 1/3. Now my next question is, can I go from 3 to 1 week? Maybe, maybe not. Right? The point is, you cannot indefinitely crash an activity. You cannot go from 3 weeks originally planned to 1 day, for example. It is not physically possible. So you have to first look into whether the amount that you want to crash is in fact permissible, is possible, feasible. Taken together, the shortened activity durations will enable us to finish the project by the due date. You want to crash in such a way that there is a benefit. Like I said, you have to focus on critical activities, and you have to focus in such a way that the penalty costs are eliminated or at least minimized. The total cost of crashing is as small as possible. Again, go back to the discussion. When you crash, typically, which costs go up? Direct costs. Which costs go down? Indirect costs. How about penalty costs? They will also go down, but they will not go down indefinitely. If the project is to be completed in 45 weeks, if right now you are taking 48 weeks and now start crashing from 48 to 47 to 46 to 45, every week of reduction helped you reduce the penalty. But once you have reached 45 weeks, which is your deadline, do you want to crash further? Maybe, maybe not. You may be happy to complete the project in 45 weeks because that is your deadline. But, like I said, it may be worth exploring the reduction of the time taken for the project to 44, 43, even though the deadline is 45. Why? Because you can take your employees and then put them in a different project. And your indirect costs will reduce, right? If you go down from 45 to 44 to 43 to 25 to 12, every week you reduce, your indirect cost is going to go down. However, for every week you go down, your direct costs are going to go up. So you got to see the cost benefit. You got to perform the cost benefit analysis and then only make a decision of crashing. So benefit of crashing is reduction in indirect and penalty costs. The cost of crashing is the direct costs. If the benefit is more than the cost, you go ahead and crash. Otherwise, you stop crashing after the deadline is met. Steps in project crashing. The first thing you got to do is compute the cost per time period. Assume crash costs are linear over time. So again, these are some of the assumptions that we make in crashing which may or may not be practical. So you have to keep that in mind. When you're actually performing crashing, you have to keep in mind that the assumption is linear. Meaning, if you go from 5 weeks to 4 weeks, the cost structure will be the same as you going from 4 to 3 weeks or 3 to 2 weeks. Okay, so for every week, the cost and benefit are going to be identical. So what is the crash cost per period? Crash cost minus normal cost divided by normal time minus crash time. Let me show you this in an example here. So if you look at this example, let us focus on activity B. What is the normal time for activity B? 3 weeks it takes. But the least amount of time that you can take, which is called the crash time, is 1 week. So you can go from 3 to 1. So that is the denominator here. Normal time minus crash time is 3 minus 1. Now, for you to complete this activity B in 3 weeks, it costs you 30,000. However, if you want to go from 3 to 1, it's going to cost you $34,000. 34 minus 30, it costs you $4,000 more to go from the original 3 weeks to 1 week. And this 4,000 divided by 2, because you're reducing it by 2 weeks, and we are assuming that the cost structure is linear, the crash cost per week is $2,000. So if you go from 3 to 2 weeks, it's going to cost you 32. If you go from 3 to 1, it's going to cost you 34. So similarly, we have calculated the crash cost per week for all of these activities A through H. Clear? Let me look at one more example. Activity E goes from 4 to 2. You can reduce it by 2 weeks if you wish. But the cost is going to be going up from 56 to 58, 2,000. So for $2,000, you can crash 2 weeks. So per week, it is $1,000. So similarly, we have done the others. Now let's go back here. So using current activity times, find the critical path and identify the critical activities. You all know how to do this. This is the critical path method, which we have discussed in detail. If there is only one critical path, then select the activity on the critical path that can still be crashed. So if you have gone from 3 to 2 to 1, you can't go any lower than 1. So check if it is still possible to be crashed. Second, has the smallest crash cost per period. So if you have two activities which are both on the critical path, which can still be crashed, then you pick the one with the smallest crash cost per period. So for example here, all of these three activities have the same crash cost per week. And two of these are on the critical path, right? C and E. Which one would you pick, either one is fine because they're both $1,000. But if the tie was between, let's say, G and H, both are on critical path, both can be crashed. Let's assume the cheaper one will be to do G, because if I reduce G by 1 week or H by 1 week, the project will still be reduced only by 1 week. It doesn't matter which one is reduced by a week. So that is what I'm talking about here, has the smallest crash cost per period. Now this is a little tricky, which is better explained with the example at the end, in which we'll get to in less than a minute. If there is more than one critical path, then select one activity from each critical path such that each selected activity can still be crashed, and the total crash cost of all selected activities is the smallest. And there may be activities which are common to both the critical paths. So, as I said, this will become clear in a minute. Final step is continue with these steps until the desired results are reached. So you don't have to do it one time, 2 times. You can go through several iterations. We'll see that with an example. We already saw this, how we calculated these numbers. Now let me get to this example. This example should make it very clear for you. Now, this is the same example we had looked at earlier in the critical path method. Okay, the only thing new here are all these numbers, which I will explain. But these are activities A, B, C, D, so on. These are the earliest start, earliest finish, latest start, latest finish, the activity duration. And if you recall, we had looked at these 4 paths to go from start to end, A, C, F, H. It takes 9 weeks on that, 2, 4, 7, 9. A, C, E, G, H, A, C, E, G, H takes 15 weeks, 2, 4, 8, 13, 15. A, D, G, H, B, D, G, H, the times are given. Now, up to this point, nothing is new. So what is new in this crashing example? The 3 costs. Now the first cost is penalty costs. It costs you $5,000 to go beyond 13 weeks. So if the project takes 14 weeks to complete, it will cost you $5,000. If it takes 15 weeks, it will cost you $10,000. If it is 16 weeks, it will take you 3 extra weeks, $15,000. So right now, how long is this project taking? We know the longest path is ACEGH, 15. That is the total time currently taken for this project. So we are late by 2 weeks. So my penalty cost is $10,000 or $5,000 per week. So I better do something about it. Indirect costs in this project is $1,800 per week. So right now it takes 15 weeks. For each of the 15 weeks, it is costing me $1,800. CCW here is crash cost per week. So where did we get this number? These numbers were obtained directly from here. So all I have done is taken this number. For A, the crash cost per week is $750. B is $2,000. So we have basically put that here, $750, $2,000, so on. Now the question is, how do we reduce the time taken for this project? How do we reduce the total cost for this project? Now tell me, which activity would you crash first? Would you crash F? Nope. Why? F is not on the critical path. This is my critical path, the longest path. We all know how to determine the critical path. These are the activities with 0 slack. Okay, whereas these are the activities with some slack. 10 minus 4, 6, 13 minus 7, 6. B, D, same thing, they have a slack. So I wouldn't even consider B, D, and F in the first iteration of crashing. So now my candidates for crashing are A, C, E, G, H. So tell me which one among these. Does it matter in terms of time which one you pick? Not really. Because reducing A by 1 week is the same as reducing C or same as reducing G by 1 week, because this whole path will go down by 1 week. So tell me what the criterion is going to be. It is CCW, crash cost per week. How much does this cost? 750, 1000, 1000, 1500, 3000. So no brainer. The activity that is going to be crashed is going to be A. By how much? For that I have to go back here and see. How much can I crash A by? Just 1 week. You can't do more than that. So I'm going to reduce A by 1 week. If I do that, now let's look at each of these paths. Now, what will happen to the time taken to ACFH if I reduce A by 1 week? The path's time will reduce by 1 week, because A is part of this path. So I'm going to go down by 1 to 8 weeks. What happens to ACEGH? It will reduce to 14 weeks. ADGH will reduce to 12 weeks. BDGH will reduce to, I hope all of you caught me, BDGH will not be reduced. Why? What we are reducing or crashing is A, and BDGH does not have A on its path, so it will remain at 14. So after the first iteration of crashing, I have reduced the time taken for A at a cost of $750, but I have saved $5,000 in penalty and also have saved $1,800 in penalty. So $6,800 minus $750. So I am really getting a net savings of $6,050. Make sense? Good. Now, do I want to go further to the next iteration? Absolutely. Why? Because my deadline is 13 weeks. I'm still taking 14 weeks. And I hope all of you recognized that you are seeing this for the first time in this class at least, which is there are two critical paths. ACEGH is taking 14 weeks. BDGH is also taking 14 weeks. So you have multiple critical paths. This is a critical path. This is also a critical path. Now, what is the only activity which is non-critical now? F. Because F is neither on BDGH or on ACEGH. And that's the only such activity now. So now, what are my options? Out of these two paths, which are the activities that are common? G and H. So I can crash either G or H. Are there any other options? Can I crash A? First of all, no, because I've already crashed A to the maximum extent in my first iteration. So okay, can I crash C? You haven't crashed C, but there is no point now crashing C. Why? If you crash C, only this will reduce by 1 week to 13, but BDGH will remain at 14, which means the project will still take 14 weeks, which means you will still incur indirect cost of $1,800 for 14 weeks, and your penalty will still be there for 1 week. So why would I even spend that $1,000 to reduce the time taken for C? Similarly, E, I wouldn't do that. I wouldn't just crash B. I would not crash just D, the only two activities I could crash independently are G and H. However, I can crash B and C together, B and E, D and C, D and E. So tell me, how many possibilities? 1, 2, 3, 4, 5. You do the math. The first option costs you 2,000 plus 1,000, 3,000. Second option, 2 plus 1, 3. Third option, 1 plus 1, 2. 1 plus 1, 2. 1.5, 3,000. So obviously the best option is the 1.5 corresponding to G. Now go back and see if you can crash G by how much? Yes, you can go from 5 to 2 all the way. So you can crash it by 3 weeks. So no problem. But I'm going to crash it only by 1 week to be safe right now, because let me look at the penalty costs. Let me reduce the penalty cost to 0. Right now I am at 5,000 because the time taken is 14 weeks for the project. Originally it was 15 and I was incurring $10,000 because I was late by 2 weeks. Now I'm going to reduce G by 1 week. So will this reduce by any amount? Nope. G is not part of that. So it will remain at 8. This path, yes, will reduce to 13. This path, yes, to 11. And this path to 13. So we still have 2 critical paths, and my project is now completed in 13 weeks. I don't have any more penalty costs. My indirect costs are $1,800 per week for 13 weeks. And my activity G and activity A are the 2 that have been crashed by 1 week each. Now, would I go further down from 13 to 12 to 11 to 10? The answer to the question is possibly. In terms of customer satisfaction, you are meeting the deadline of 13 weeks. So you may say, nah, I don't think I would want to go any further. However, in terms of cost structure for your company, you may want to consider it. If you want to go down from 13 to 12, no further savings in penalty, because at 13 your penalty is 0. However, your indirect costs can be reduced by $1,800 if you go from 13 to 12. So the point is to check if the direct cost increase can be less than that $1,800 that you are going to save. So let's explore. So the options are still the same as before: B and C, B and E, D and C, D and E, G and H. And we already know G is the best one to crash because it costs the least, $1,500. So how much can you crash G by? You could crash G by total of 3 weeks, but one of those weeks have already been crashed in iteration 1. So in the third iteration, I'm going to crash G by 2 more weeks. So basically, you are going from 5 to 4 in iteration 2. In iteration 3, you're going from 4 to 2. So here, nothing will change. Here, you will reduce it to 11 because you reduced it by 2. G is part of this, so this will reduce to 9. And this will reduce to 11. So now both A and G are completely crashed. Now the fourth iteration. Is there a fourth iteration in this? Let's see. Now what are my options left? H cost 3,000. Why would I do that? Because the only saving I'm going to get to go from 11 to 10 is $1,800. But it cost me 3,000 to accomplish that. So I would not crash H. The other options, B and C together. How much does it cost? 2 plus 1, 3,000. Nope, I wouldn't do that. Anything that goes with B is already more expensive than 1800. It's 2000 here. Let's look at D and C. Still expensive. 1 plus 1, 2000. 1 plus 1, 2000. So I would not crash any further because the net benefit is not there. So my crashing will stop now. So ultimately, in these 3 iterations, what I have done is gone from 15 weeks to 11 weeks to complete the project. It has cost me 750,000 here because I went down by 1 week for A, then I went down by 3 weeks for G. 1 week here, 2 more weeks here. So my total cost for G was 4,500 plus 750, 5,250 is what I expended. However, what did I save? In terms of indirect costs, I went from 15 to 11, which is 4 weeks times 1.8, which is 7,200, and I also saved 2 weeks of penalty, which is 10,000. So I saved $17,200. Okay, so definitely there is a net benefit in doing this. I hope you understood the crashing concept and the example. Feel free to listen to this again slowly, and if you have further questions, we can always answer that during the chat sessions and office hours. Thank you.